Welcome to the 2024 Winter Classic Student Cluster Competition Studio Update Show. Now, here are your hosts, Dan Olds and Addison Snell.
Hello, Dan Olds here, and we have completed another module in the 2024 Winter Classic Invitational Student Cluster Competition, and one of our stalwart mentors has been AWS, and they're back again this year. And let's introduce the Chiefs on this mentor team. We've got Evan Bollig, who you've seen before, and Brian. I'm not sure I'm going to take a run at that last name.
It's Shervin, but don't worry, no one gets it. Yeah.
Okay, I would have pronounced the J, and I don't think that would not have been good.
No, apparently the Norwegians decided not to pronounce it. So, yeah.
So, first of all, tell us a little bit about the challenge you set up for the students.
Yeah. So, Evan and I kind of went back and forth on this about how kind of real world or how difficult do we want to make it? Because there's the response about something that it was closer to like a standard benchmark. And do we want to do something like that, or applications that are well known and there's a lot of literature out there on benchmarks? Or did we want to do something that was a bit more open-ended, bit more of a real world application, where they could, have options around, was it GPU, was it CPU, did storage have an effect? Because very often real world HPC applications, it's not just as simple as turn one knob and make it go fast. There's lots of aspects that you can change.
And that's the thing. They need to be exposed to.
Yeah, exactly. We put an effort in every year to make sure that the students get, from us at least, a true world experience. And it really is a challenge for us to expose HPC students in curriculum to that, because you can't check their knowledge with a real world application, right? And so we took an application that we thought had a lot of impact. It's one that Brian and I both worked on with our customers, and we've seen it change the world. And it was also a case, it came out of pharmaceutical and healthcare life science. It's a application that it grew in popularity during COVID, and cryo-electron microscopy is the challenge. There's a Nobel Prize for cryo-electron microscopy. There's a lot of literature growing around it, but it's something that's sort of a hockey stick in the last decade. Mm-hmm. And we threw that out in front of the students, knowing that
the app is Relion. We haven't mentioned that yet, but just throwing that in. Okay.
Relion. So we put cryo-electron microscopy out in front of the students because it is popular, it is a challenge, and to be frank, most of our customers come to us and say, we want to do this, but we have no idea how. And so thinking about their professional development, this sets them on the right path. If they want to get a job in this industry, what better way to train them in than to give them skills that even our to date most relevant customers are struggling with?
Yeah, absolutely. I want to give a shout out to the teams for doing something that not even like professional end users and scientists at some of the top pharma companies can do on their own. So big kudos. I mean, yeah, that's right.
That's a big deal. Oh yeah, absolutely. Yep. And the other thing is, even for the teams that didn't complete, just having something like this thrown at you out of the blue and giving it a try is a good war story for an interview. At least along with the skills, right?
Well, from Brian's intro, he talked a little bit about what our role as solutions architects entails. And that's our day to day, right? Somebody will call us up and say, hey, I'm really struggling with this type of workload. Have you ever seen it before? And we don't have, we could say no and pass it on to somebody else, but we don't have that in us, right? Our leadership skills sort of calls us to action to say, if we don't know it, we'll dive deep and we'll figure it out.
Yeah. And you really don't have an alternative to say, nope, not us. Thanks though.
Right. I mean, in HPC, everything is a unique challenge. We ran into this earlier this week where, Dan, I made the comment, is it really HPC if it doesn't break or burn or, fail entirely. Like that's our whole discipline is about pushing the limits, testing new things, doing new research. And so taking on a new application, what we do is we look for those commonalities, the common patterns, and we can apply those to any sort of discipline.
Yes. And I mean, I've always seemed to find, not being a real practitioner myself, but in talking to them, there's a common set of things you do, of steps you do, like starting with small runs. Well, first, making sure your environment's right and working. Test that out. Start with small runs, with small data sets, little goals before trying to run it at scale. Stuff like that. And, for performance profiling, getting rid of those bottlenecks if you can. That's all tools that they're putting in their toolkit.
That's right. So, Brian, you want to talk a little bit about the small size of the data and some of the fun stuff we had around that?
Yeah, I mean, the challenge was basically running this. There's the makers of Relion make a really good in-depth tutorial on a single particle analysis. So it is going from, admittedly, it's a small data set compared to what they run in production. In production, these data sets start at on the order of like 10 terabytes that they've got to process. And Evan, I'll be honest, I forget right now what the input data set. It's on the order of only like a few gigs, right? For Ron, yeah. So it is. I mean, it is a small. It's meant to be a starting point and be able to run some of these stages, in a matter of maybe 5 minutes to 20, 30 minutes for the longest one.
So
again, in production.
Yeah, they can fail fast.
Yeah. Right. And because in production, a real world cryo-EM sample is going to take maybe 2 weeks to process, for a scientist to process. Yeah. So, and again, the tutorial is really nice because it's got all the kind of cryo-EM specific parameters laid out for them, because that is a bit of like a dark art. And we're not expecting the students to have to learn any of that or really modify any of that. It was more about, understanding how to set up a complex environment and deal with kind of unknown data or, not just running a stock input and a standard benchmark. And we gave them a lot of leeway. Yeah. We set up the clusters with a lot of different options as well, so that they could kind of run in different directions and hopefully not bump into as many corners as we had, but bump into some edges and figure out how to solve problems. Because at least that's my feeling is, you learn best when you got to solve a problem that you're stuck on.
Yeah, that's right.
Absolutely. I'm going to throw up that GUI that you guys sent me with the results. I'll throw that on the screen so people can get a look at what the students were seeing. And it seems like, as in most challenges, the teams that got out early probably did the best.
Yeah, I would say so. So the final results that we got from teams, we set them up with all these cues and general instructions on how to run the single particle pipeline. We expected them to iterate on the individual steps and sort of play with the different instance types, do some performance testing, or at least look at the run times on things and see if they can improve the turnaround. Maybe scale out the number of compute nodes, change. Really advanced cases, change the compilers and change the libraries and everything in use. What we saw is some teams worked on compilers, some teams used different queues and instance sizes, but most of the teams just did a single pass through the pipeline, and that's as far as they got. And they didn't really take the time to go and test other directions. And part of that was because personally, I think it was because the time commitment on our workload it required more than maybe they were used to, because it wasn't your standard, HPC benchmark or a small kernel. They weren't anticipating that a single pass through the pipeline would take on the order of hours, and each step you'd have to submit, verify, and then continue on. So there's a lot of human in the loop to this process. So I would guess that they would spend on the order of like 6 or 8 hours to get a single pass done.
So yeah, that's not good. And
Well, it's again, it's real world, right? And if they
yeah,
get a single pass done, they get the data, they understand a little bit more about cryo-electron microscopy, the pipeline.
true.
They also they start to see where the hotspots are. And we had one team assess, there's a single phase within the workflow that they thought, they would put more effort into if they had more time for the week. They just ran out because they started a little later on it.
Yeah. Yeah. And we had some downtime, but did give them more time on the back end. So
yeah, we had an interesting situation. There are some automated systems around accounts at AWS that protect their customers. And, when we went from zero activity in the account to the students running full bore, it looked like it could have been a botnet or some sort of fraud. So, the automated systems fell in place and we had downtime trying to get that resolved.
Yeah. Yeah. I started receiving all these alerts and saying, oh, no, that's all not a big deal. That's not a problem. Well, it was. And went in and then had to convince them that I was me and here's the deal. And they're like, I said, well, there's some people you can call that are in your company. Well, sir, we're going to go through the standard procedure here. And actually, they were helpful and they did get it corrected fairly quickly, but it is a process.
Yeah. Yeah. You know what we should do, Dan, is we should frame that email you got about fraud, because that's the level of activity that happens with this competition, right? You go from 0 to 11. Right?
Yes. And 11, a lot of times just getting hit really hard.
Yeah.
So you don't know if someone has stolen an account and is doing Bitcoin or who knows what.
Right.
So, yeah. And, once I explained it and, told them the pattern that's been going on the last 3 years, all good, but it just had to go through their process.
Yeah.
And that's fine.
Yeah, we added time on the back end. So the students had the full week of runtime, and they had us, even during the downtime, people asking questions and we're continuing through the mentoring stuff. We gave students in the Slack channel, we had links for internship opportunities related to cryo-EM. We had an opportunity to share with them insight from our experience in the field. Like for the one piece that I want to just share here is, if any student finds an internship in scientific computing that they're interested in, they should apply for it. There shouldn't be any hesitation. They shouldn't waffle on it thinking they don't have the experience necessary, because our industry will teach all the skills that you need. What we need is butts in seat.
Yeah.
And the uphill pools aren't deep enough for everybody.
No one comes in for entry level or internship, particularly internship, knowing what that organization needs, because they're all different. And
that's right.
Yeah, that's what I'm trying to get across as well. The other thing I'm doing is, in every student interview, I'm taking some time to ask each student in turn, what interests you? What do you want to do? And it's funny, I did a survey of past participants before this edition of the competition, and most didn't know HPC was a thing before this.
Right.
After doing this, let's say about 72% want to work in it. And that's a pretty cool thing. And it's mentors like you folks that help them come to that realization. So great job. And again, can't thank you enough for all the time and for putting up with all the hassles. And these results did give us a little bit more spread between the teams. They did, but still, between first place right now after your module to, let's say, fourth or fifth place is only like 50 points.
Okay.
For all of the teams, the top 5 teams. That's really close when there's still
they gotta stay on the ball.
There's another 200 points out there.
Right.
So, yeah. And as we saw with AWS before, the legendary Open Foam Challenge, where a team decided to go ahead and let's course in the mesh, it worked. And they just meteored up from a low 5th place to 2nd place by 2 points, and then won it in the interview. And that was really cool to see. It's one of the most dramatic finishes we've had. And I remember doing this same interview with you guys after that, except Brian, you weren't there. But your Open Foam guy was openly giggling because he left that trap door open. He was hoping someone would pull the right book from the bookshelf, see that trap door open, go down the stairs and dig in, and one team did. And it was really cool to see. They were incredibly fired up. Good deal. Good time.
Trapdoor this year? We actually limited the trapdoor this year. So we when we went through and we were doing the grading, we weighted the different pieces that we were grading in a way that we didn't want one team to come out ahead just because they had found the loophole. So there was a small component for that, but it only accounted for 10% of the scores.
Okay. Yeah, that is an interesting approach. I like that. But did anybody find the loophole?
Not really. No.
Okay.
So the loophole, it had to do with the resolution of the results. And and we did, if basically it came down to if the teams didn't really try, they would slip down in that 10% because they weren't getting a fine enough resolution. And we had one team that held close to the tutorial, worked through all the steps properly, and they were able to fully resolve the sample. And the other teams skipped a couple of optional steps because they were running out of time or it was difficult to get the applications installed, and their resolution started showing as much lower than the others.
I see. Okay. And that's kind of shades of Open Foam, is make sure you know what's being asked for.
Yeah. Well, those
and provide stages, up to that point.
Right. The optional stages, when you're running this stuff in production, you won't do the optional stages in your testing mode. But when you go to production, if you're going to produce a result for publication or for sending to a customer, right, you're going to go through those optional stages as required, because the output data you get from these pipelines, your goal is to get as fine resolution as possible.
Mm-hmm. Yeah. That is really cool. I also noticed that that you called out some of the reports that they turned in, and there were some good ones. One I love for the number one team, a little terse, but had all of this, and this. But I like the terse thing. That was good. That was good. That was efficiency on their part. Yeah.
In a report, we like reproducible research. We like to know what someone else has done so that we can do it as well. And when a report it's literally just a table and then a README to the side of that says, look in this directory for any data. Yeah. That is hard for me to interpret, hard for me to reproduce the research. But the data that's in the table is incredibly valuable. And when you get into their directory with the work, they did show all of their steps. They have all the output logs. They have all the output data. Like, everything is right there. So you can reproduce that if you need to.
It was very cool, the whole thing. And they did get a up close and personal look at real life in HPC.
That's right.
That's the goal.
Yep.
So, yeah. So thank you both. Thank everybody who is involved. You got to thank Ian Colley as well. Mm-hmm. And we'll see you next year. Commitment? Yeah, you nodded. Yeah, you're in. Okay, good.
Yeah. I love doing this. I love working with these students.
Is it?
I got to tell you, Dan, actually at Supercomputing this last year, I ran into a student that had gone through the competition previously. He came over to our booth specifically to talk to me and to remind me, thank me for mentoring. And he's now working for another company in HPC, right? Like it set his career up. So I'm really excited to see where these students go in the future.
We have students that are at Sandia. One of the early ones from the first time you guys mentored from Fayetteville. Mm-hmm. Got a call from him saying, would you mind giving me a reference? Absolutely, no problem. Where? Lawrence Livermore. He locked that down. Nice. It is there today. And that's fantastic. That's the whole point of this. And it seems to be working about 60 students at a time. So we'll keep pushing. But thank you both for your time this last week and before, and for this. It was great talking to you. And again, we'll line you up next year.
Sounds good. Thanks, Dan. Thanks, Brian.
Thank you.
Thank you for watching this episode of the 2024 Winter Classic Invitational Studio Update Show. For all the latest news on the competition, check out our official media partner, HPC Wire. We're also on social media at the handles above. Give us a follow. We'd love it. And please visit our website at www.winterclassicinvitational.com. Thank you to all the student teams, mentor organizations, and sponsors for making this competition possible. Stay tuned for more.